So, welcome to a new session of the seminar Information Extraction. My name is Lucas Veneziano and I'm presenting Never-Ending Language Learning. The motivation is we have much facts on the internet which we want in a knowledge base that grows every day or iteration in our system that we look at. And it gets every day more accurate by using the facts that we learned yesterday. It uses state-of-the-art techniques of information extraction, and so the university in the Carnegie Mellon University in Pennsylvania started a project called NEL, Never-Ending Language Learner, in the year 2010. Which is still computing. How does it work? NEL crawls the internet for information, evaluates this information, stores these beliefs in a global knowledge base, and iterates over time with the received knowledge to get better results. Or the facts that we gathered yesterday, we use this to get better results. The results are stored as candidates for a belief, and the candidate can graduate to a belief which is engraved as a belief in our system, or in the paper they said that it could also be degraded, that a belief isn't longer a belief and gets back to the candidate. We have, in the NEL, we have some subsystems with different approaches. These subsystems take data from different resources, for example, the internet and many web pages. Then they extract information from the data and promote candidates for the knowledge base. Then a knowledge integrator decides if a candidate is good enough to get to a belief. And the beliefs can also be used by the subsystems to get new information from it. The knowledge integrator, as I said, decides if a candidate gets to a belief. For this, he gets candidates which where part is the probability with which a candidate is assured, and a summary which includes the fact why a candidate should be a belief, and a formal definition of the candidate. The subsystems read from the data resources and the knowledge base, as I said before, and propose some candidates to the knowledge integrator. And because of the different approaches, we get uncorrelated errors and multiple types of interrelated knowledge, so that so that the knowledge integrator can see that different approaches have the same result, and can for that be more sure that a candidate can get a belief. The knowledge base consists of the beliefs and the candidate facts. Beliefs are with a posterior probability of more than 0.9, and the candidate facts are lower, have lower posterior probabilities. The candidate facts and the beliefs retain the source justification for each belief. The data resources can, as I said, be internet pages or just corpora of internet texts, or anything else that we could use, like search engines we can query or something else. In the original training set, the internet pages were given was in a number of 500 million web pages that the different subsystems could use, and some search engines. For the subsystems, I have taken two examples, the coupled pattern learner and the coupled seal. The coupled pattern learner is a free text extractor which learns contextual patterns and relations. It uses part of speech tagging and gives probabilities higher than 0.5. The probabilities are relative to the number of promoted patterns, and so we have the formula of 1 minus 0.5 to the power of c. In experiments, there were used the OpenNLP to check if the accuracy of a fact is good or not. The coupled pattern learner extracts patterns and instances. Patterns are used for categories and relations. Category pattern gets promoted if a noun is followed by a verb in a sentence that was used before as an instance. And for relation patterns, the arguments for relation patterns we promote these in which a promoted relation that we had before in the knowledge base occurs more than once. So I think it's the most intuitive solution. We see an instance more often, in instances more often some patterns, and so we promote it to the knowledge base for later learning. The instances are promoted are promoted like this. The relation instances are promoted if both placeholders of a fact that we saw on the weight page are valid for the categories, and it's the same for category instances. If we have a proper noun phrase which is valid for the specification we had for the category, we use it as an instance for this category. Coupled seal is a semi-structured extractor which queries the internet for beliefs. This means we have a fact in the knowledge base and query, for example, a search engine with this belief, and then we get new instances of this predicate. Yes. And the coupled seal especially uses mutual exclusion for relationships, mutual exclusion relationships to make better results. The probability method for for coupled seal is the same as for CPL, and the other subsystems of NEL have different probabilities, so that we have some systems which only give probabilities less than 0.5, and these give only higher probabilities. Coupled seal searches, as I said, the web pages with some predefined searches the web pages with some facts, and for this, in the first iteration, we predefine some seeds, and afterwards we use seeds we get from the knowledge base we got from earlier iterations. The original algorithm was seal, which had no concept of mutual exclusion. And C-seal, also coupled seal, first extracts new elements by this original algorithm and then filters the candidates that violate coupling. So if a car is from brand BMW, then the car can't be of brand Audi. I will show you some of the data we can see on the web page of NEL. There is this knowledge base browser where we can look at the categories and relations. For example, yeah, we can see an animal, some facts that some elements that are a fish and an element, yes, a shark is a fish and an animal. And then there are the categories. For example, books. There we can see which elements were promoted as books or believed as books. And we can see that the confidence is 100%, and the date it was learned, and in which iteration it was learned. I think that NEL today now has more than 700 iterations, and so the database is very large. Yeah, if we search, for example, for broccoli, we can also see in which categories broccoli is, and for example, also which subsystem, like CPL we saw earlier, has promoted this on February 26, 2011, and also why. Oh, super. I will search it again. Yeah, or if it takes too long. There we can also see with which probabilities it was promoted from which subsystem, and also why it has now 100%. I don't know why it doesn't work. Earlier it worked. And we can also see in a category like food that broccoli is in this category, and we can see if we click on broccoli, which are the beliefs that we have about broccoli. Like broccoli is a vegetable, and we can help the system by marking something as correct or as incorrect. Yes. Over the years, it's only 3 years, but it there were many improvements by the original researchers group. There were 20 published papers in the 3 years. I can't talk about all the improvements, but I will show one especially. It's about human supervision in such a system. And like we saw, we can there are two approaches of human supervision in the system, one active and one passive approach. Passive means on the web page of the system, we can a human can go to the web page, and the web page waits passive for interaction of a human, and on the web page you can click this is correct. Or the active approach is to use a community, an internet community, to get better results. So the system autonomously asked Twitter users about a fact. And yes, there are many problems when we accept human supervision. The computer must autonomously get help from the humans. as I said, and then there's the question which knowledge should get out to humans' attention. So we can't ask humans about all the facts, because some facts in the knowledge base or some relations in a knowledge base humans wouldn't get and couldn't answer if it's correct or not. And there's the question, who are the humans that the machine should look for help? If we go to one community which is about cooking, we can't ask the humans in this community if some car is of some brand or not, because they aren't. The community isn't good for this question. And another question is how to understand humans' answer. The question is, I ask a question in a community like Yahoo Answers, and in Yahoo Answers it is normal to write a long answer in natural language, and the system has to understand this. Normally we can't understand a long answer to a short question, and so normally we ask just to answer with yes or no. And then there's the question how to infer from humans' answers. If there is a huge answer from a human in Yahoo Answers, how do we deal with the facts that come in this answer? Yes. For this approach, the NEL research group introduced conversing learning for this actively seeking for information. And with this approach, we have only a few facts that are going to be validated by the community, because most of the facts can't be validated by a community. And this conversing learning is an advancement to the SS-Cloud algorithm. This algorithm takes facts from the knowledge base, build it to a human understandable question, queries a web community like Twitter or Yahoo Answers with this question, and gathers and resolves answers. Normally we normally we classify answers as positive or negative, and because this is very difficult for our system, we build a question that asks for yes or no, and and then it combines the answers and produces a combined opinion, even of different communities. The NEL has a Twitter account. I will show you. Where the system always asks if there's a new candidate, and you can click on the link and answer with yes or no. If we compare Twitter to Yahoo Answers, we see that the unresolved answers in Twitter are less than in Yahoo Answers, and that Twitter and Yahoo Answers users disagree in the same question. So that a Twitter user would normally answer in a short question, and a Yahoo answer would be longer, and even the facts in the answer would be different from community to community. And I criticize the facts from the research group, because we can't see why Twitter is only 51, has less questions than Yahoo, and so the the comparison isn't quite good. Unfortunately, there's no data how this active seeking procedure improves the accuracy of NEL, but in an earlier version of NEL, there was a weekly human supervision. So every week, there were some researchers who tested some facts and said this fact is correct and the other is not. And so we could, with just 5 minutes per week, we could improve the accuracy from 71 to 87%. And so I think that this community approach would even get better accuracy. NEL was tested with special test conditions. The first version had in each iteration just 3 of the 4 subsystems, CPL and CCL, as we saw, and CMC is another subsystem. And only every 10th iteration there was the rule learner used, which relation learner, sorry, which tests for special relations. And in these test results, the proposed outputs were filtered by human a few minutes per iteration, which I think distort the results. So we can't see what happens if the system works completely autonomously. In the training set, there were some categories and some seed instances and some patterns and some relations with each. Also some instances and some negative instances. In the paper there was said that there were some relationships between categories, but not how many. The runtime in the original version was 67 days, which were 66 iterations, so we can say that one iteration takes at most 1 day, and about 242,000 new beliefs were gathered, where 95% were instances of categories and 5% were relations. Over time, we see that the number of promoted beliefs gets lower, but is always about 3,000. New promoted categories and about 200 new relations, and after a bit of time it doesn't go down, so we could assume that the system always gets better. There are some peaks on the relations, which are because of the relation learner, which is very important for the relations and only gets used every 10th iteration. Yeah, and we can see that the precision gets lower every about 20 iterations, and that's why they later introduced weekly human supervision sessions, because the precision in the end of the test run gets lower, and we can see that the number of promotions is also lower because many facts are given in the knowledge base. Yes, that's it. And do you have any questions?
Okay, thank you. I
had a question about the mutual exclusivity thing that you mentioned. I wasn't sure that I understood it, but is it that the system is somehow aware that some relations are the opposite or exclude other relations, and if so, how does it achieve that?
Yeah, the mutual exclusion is we use the system to get some patterns which say that, for example, this if a car is of a brand BMW, then it can't be of another brand, and these patterns are used by the other subsystems.
So it's for a given relation which it has learned, it knows that it can only have one argument?
Yes. Yes.
But it doesn't make extrapolate between relations like knowing that alive is the opposite of dead, for instance.
This could also be possible, yes.
But I guess, did the paper explain, because for a given relation, you could, if you're using frequency only, I mean, I'm alive and I'm therefore not a parrot, doesn't work. And you would expect that those, the frequency would...
I don't think that the system could get that if I'm alive, I'm not a parent. So...
if you're dead, or you're...
Yeah. I don't think that this system could learn this. It's more than... it's more of, like I said, the brand of a car or something like this. No further questions?
So how large is NEL right now?
What?
How large, I mean, how many facts are in there?
Right now, I don't know exactly, but we can look. I didn't look for it. I don't know how many there are.
Okay, so but if you're right there, what are these categories exactly? I mean, it's not a taxonomy. If you go back to the categories.
Yes.
So the categories are somehow inferred or extracted as well, right?
Yes.
Okay, can you scroll down a bit? Yeah, so we can see. Okay, so it's a taxonomy, right? So it's a relation between some entity and this category.
Yes.
Okay.
We can assume that there was some text which said that, for example, in actor, that Adam Sandler is an actor, and the system sees that Adam Sandler is an actor and promotes this as an instance of some other category, and if it sees another person who is also an actor, it promotes this category as a new category, so we can use it for other.
Can you look up Ronald Reagan? I'm just curious to see about actors who are also other things, like in this case the president.
Oops.
It's R-A-E.
R-A-E.
R-E-A, sorry.
Yeah.
Yeah.
Well. This is very slow. I don't know why.
So
he's just male. We don't know anything about
He's
him.
also a celebrity, but it's not confidence.
Okay.
But if you go back, there was also the president somehow, right?
Yeah, there was President Ronald Reagan. I guess is a different person.
Oh, okay. Maybe the system didn't quite aware that it is the same person.
So it's assuming that these categories are mutually exclusive. Then.
Yes.
In this case, at least. So does the system somehow also infer new facts from the ones it has already?
Yes.
So it has to somehow learn inference rules as well, right?
Yeah. I don't know how it does this.
Okay, but it does.
Yes.
Do it. Okay. Yeah, any more questions? Okay, thank you again.